So I'm doing homework number 1, problem 20.25. And part A is asking how long does it take for light to travel through a 3.0 millimeter thick piece of window glass. Pretty straightforward, asking how long, therefore I put T because it's time, the time it takes for the light wave to travel. And we're given that the piece of glass is 3.0 millimeters thick, and that just means that that is the distance it's gonna take for the wave to travel through this medium, and therefore D is equal to 3.0 millimeters. We convert that to 3 times 10 to the negative third meters, just to make it easier for conversions later on. And then T, of course, is our unknown. So we've listed our unknowns, and now we can move on to solving. So let's follow over here. I write down distance equals rate times time because that is our most simplest relationship, and we're trying to find time, so we can use this to help figure out what else we have to do next. So distance, in this sense, is just distance, which is the thickness of the glass, and our rate is the velocity of the wave through the glass material times just time. Time is time. So we have our distance, but we don't have V glass, and T is our unknown. So we have to find V glass before we can figure out and solve T. And how do we do that? Well, let's go look at our equation sheet, and we find that N glass equals C over V glass. C is speed of light, V glass as in the velocity of glass, and N glass as in the index of refraction for glass. And we can see that because it has V glass, we can solve out for V glass, which is going to be C over N glass. So we have both the speed of light, which is constant, and then N of glass is just from the chart, a number from the chart. So we replace this into our equation for V glass, and then we get this. D equals C over N glass times T. We know the speed of light, we know the index of refraction for glass, and we know the distance. Now our unknown time is the only variable left. So we solve for time by just isolating time and moving the variables to one side, and then we plug and chug, and we get 1.5 times 10 to the negative 11 seconds. And this is where it comes in handy to have that in meters instead of millimeters, so you don't have to convert it. Moving on to part B, it is asking through what thickness of water could light travel in the same amount of time. So the same amount of time just means we're using the time from part A, and thickness, as we had just talked about, is the distance of this wave traveling through this medium. So basically we're looking for D, even though it's asking for thickness. And time is just from part A, which is 1.5 times 10 to the negative 11 seconds. And then the index of refraction for water is given to us from the chart, which is 1.33, and we put that in our list of things to know because now our medium has changed. It's no longer glass, it is water. But we realize that this is all similar variables to part A. So our equation of D equals V material times T applies to this too. But instead of V of glass, it's V of water, and we can use the substitution for V of water equals the speed of light over the index of refraction to replace this, because we know C, and we know the index of refraction for water, but we don't know the velocity again of water. So we just plug and chug, and we get 3.4 millimeters.